Hi, this is Rajesh Gudipati. Today we are going to discuss about construction of hyperbola. For that I selected one problem. The distance of the focus from the directrix is 50 mm and eccentricity E equal to 3 by 2. Construct a hyperbola, draw a normal tangent at any point. For that one, first we need to consider the eccentricity. They given as 3 by 2 and the given distance of the focus from directrix is 50 mm. That means CF equals to 50 mm. Using this information, we need to identify the position of CFV, which is directrix point, focus point or fixed point, and vertex point V. To find out this 3 points position, we know that eccentricity E equals to VF by VC, that is eccentricity ratio. They given as 3 by 2, and we know that distance from fixed point to directrix is equals to VF plus VC. By considering the ratio parts, we will get VF is equals to 3 parts and VC equals to 2 parts, and it will be 5 parts. 5 parts is equals to 50 mm and 1 part is equals to 10 mm. With this we will get VF is equals to 3 parts equals to 30 mm. That means position of V from fixed point, that is focus, is 30 mm. Like that we can find out the position of V with respect to F or position of V with respect to C from the given information. First of all, we need to draw the directrix line. We need to draw the directrix line and axis line. These two lines should be perpendicular to each other, and then we need to locate the position of point C, and at a distance of 50 mm from here to here I am going to take the distance as 50 mm, and this will become point F. So based on the calculations, we got that position of V will be at a distance of 30 mm from V. That is, V will be at a distance of 30 mm from F. So here this distance is 50 mm and from V to F distance will be 30 mm. Like this we need to find out the position of V, and then we need to get the points. To get the points, first of all we need to draw one vertical line passing through the V and taking the VF as radius, V as center, draw one semicircular arc that gives you the point E1 and E2. Point E1 and E2. Like this you are going to get the 2 points. Then extend CE1 and join CE2 and extend it. Like this you will get a CE1 and CE2 lines like this. You can observe that CE1 and E2 VF. So like this, first we will get the extension lines and position of the required points. After that we need to go for the taking the points in the equal interval 1, 2, 3, 4, 5, 6. As it is a hyperbola, we can take up to 6 points. After taking the 6 points, passing through these points, we need to draw the vertical line that will touch the 2 extension lines at 2 different points, and it will become 1 dash and 1 double dash. And if we draw a vertical line passing through the 2, we will get 2 dash and 2 double dash. Vertical line passing through 3 gives you the 3 dash, 3 double dash, 4 dash, 4 double dash, 5 double dash and 5 dash, 6 dash and 6 double dash. Like this, first we need to find out the points on the extension line with respect to this points which we considered after V. After we, with an equal interval of 1 centimeter, we considered some points. From there we got the points on extension line. Then what we have to do is, taking 1 dash as radius, focus F as center, we need to cut the arcs, cut arc on 1 dash and 1 double dash. That gives you the P1 dash. Similarly, taking 2 dash as radius, focus F as center, cut the arcs on 2 dash line and 2 double dash line. F as center, 2 dash as radius. Similarly, 3 dash as radius, F as center, cut the 3 line above and below. Taking 4 dash as radius, F as center, cut the line, 4 dash line. Similarly, 5 dash as radius, F as center, cut the 5 double dash line. Similarly, taking 6 dash as radius, F as center, you'll get the arc like this. If you take n number of points, the curve will be, the intersection points will be going in the same pattern. And if you join all these points using your free hand, you'll get a smooth curve like this. So these are the points that we will get, and if I join them, this will form the hyperbola. So on this hyperbola, if you observe, this is a smooth curve. We need to construct the normal and tangent. Randomly select any point on this hyperbola curve. Here I will take the hyperbola point on the hyperbola curve and name it as Q, and here it is focus VF and vertex V and directrix C. Then join the Q and F, perpendicular to QF, passing through F. We need to draw one perpendicular line. Here it should be perpendicular line. This line will go and intersect with the directrix, and it will give you the point T. And if I join the T with Q and if I extend it, that will be the required tangent T dash, and perpendicular to this T dash, if I draw one line passing through the Q, that will become your required normal N dash. You can observe the final smooth curve. This is hyperbola, and this is the normal, and this one is tangent. T dash, N dash, C. This will be V, F. Axis line and directrix, and then finally you need to go for the dimensioning. So here we need to go for the proper dimensioning using the dimensioning procedure. This distance is 50, and we got that CV is 20 mm, or VF is equals to 30 mm. So in this way we need to go for the dimensioning, and finally we need to go for the naming as hyperbola, normal N dash, tangent T dash. So using the parallel lines help, we can give the naming properly. So use the perfect procedure to write the names. So this is what construction of hyperbola using eccentricity method. For any queries, you can give your suggestions in the comment box. Thank you.